Are you pouring millions into data cleansing? You're treating the symptom, not the disease. I'm Randy McClure with SC Tech Insights. When we share data between systems without sharing context, we destroy data integrity. In this quick preview, I'll show you why dumb integrations destroy your data's truth and how to build intelligent connections instead.
So today, we're going to objectively dissect the root causes of enterprise data failure, and more importantly, the architectural shifts required to actually fix them. Our goal here is to move beyond temporary patches, and finally address the structural integrity of how our systems communicate. We've structured today's briefing into 4 key areas. First, we'll look at the enterprise integration myth. Second, defining the truth crisis. Third, the real risks of data cleansing. And finally, semantic interoperability solutions. Let's jump right into part 1, the enterprise integration myth. To properly diagnose this problem, we first need to establish a clinical baseline. Let's look at how AWS defines standard data integration. They call it the process of achieving consistent access and delivery for all types of data in the enterprise. Now, mechanically speaking, standard data integration absolutely works. It moves data from point A to point B without fail. But as an engineering framework, it has a fatal flaw. It assumes that successful transmission inherently equals successful comprehension. And in a complex enterprise environment, as we know, that assumption simply doesn't hold up. The core engineering challenge really comes into focus when we contrast these two frameworks. On one side, you have what we call dumb integration. This is focused merely on data being exchanged. On the other side is the actual solution, semantic interoperability, where data is actually understood. A massive blind spot of standard integration is that it relies on systems transferring data completely devoid of context. It's essentially an infrastructure that checks a box to say, yes, a file is delivered, without ever verifying if the receiving system has the programming to interpret what that file actually means. The research provides a really excellent technical illustration of this failure. It notes that this operates exactly like a flawless postal service delivering letters in a language no one comprehends. Think about it. You have a logistics network that perfectly transports a sealed package across the globe right to your desk. The delivery integration itself is flawless. Yet, when you open the package, the documents inside are encrypted and you don't have the cipher. The data arrived, but its utility is absolutely zero. Unfortunately, this is the current reality for most of our digital supply chains. That brings us to section 2, defining the truth crisis. When systems share data without also sharing the context of that data, an organization inevitably enters a state of operational blindness. For some context here, let's look at a baseline definition of data integrity from IBM. They define it as the assurance that an organization's data is accurate, complete, and consistent at any point in its lifecycle. Now, this is the gold standard every CIO aims for. However, true data integrity demands that information remains accurate and consistent as it moves. And mathematically speaking, that is an impossibility when receiving systems are routinely misinterpreting incoming context-free data. The exact moment a system has to guess the meaning of a data point, your data integrity is destroyed. Let's look at the actual mechanics of this breakdown through some common operational disconnects. For instance, a supply chain system transmits the status, shipped. To the transmitting warehouse, that simply means a shipping label is printed. But the receiving customer-facing system interprets shipped as the product has physically left the facility. Or consider the financial and marketing systems. They pass data regarding revenue recognition, yet each department operates on entirely different accounting definitions for that exact same term. These aren't just minor software bugs. These are fundamental interoperability failures that completely cripple downstream analytics and ultimately lead to misguided strategic decisions based on corrupted insights. Which leads us to section 3, the risks of data cleansing. To cope with these systemic integration errors, enterprises routinely misallocate massive amounts of capital into reactionary workflows. But relying on data cleansing is a profoundly flawed business strategy. As you can see, AMOS data cleansing is merely treating the symptom. It's a highly manual, error-prone, and capital-intensive process that happens only after the data has already been corrupted by the integration. It entirely ignores the underlying disease, which is the missing business context. The strategic implication here is severe. Organizations that fund massive data cleansing departments are essentially paying a recurring tax on bad architecture, rather than investing in a permanent engineering fix. As the research so bluntly asks, why do we continue to build these data bridges to nowhere? Investing in these disjointed digital exchanges creates a sprawling infrastructure of dead ends. Every single time you build a new integration without establishing shared business definitions, you are consciously choosing to break data integrity at the very point of connection. You are effectively guaranteeing future operational expenses just to decode the data you already pay to transmit. Finally, let's turn to Section 4, Semantic Interoperability Solutions. To eliminate these endless cleansing cycles and stop operating in the blind, leadership absolutely must reorient toward a foundational architectural fix. This required strategic shift is beautifully captured in this definition of semantic interoperability from the EIF. It is simply ensuring what is sent is what is understood. Now, this isn't just an IT buzzword, it's a rigid architectural standard. It mandates that the transmitting system and the receiving system share exact programmatic operational context. It guarantees that a date field meant as a purchase date is never computationally mistaken for a ship date once it arrives. To actually execute this architectural requirement, enterprises have to adhere to four core directives. One, establish clear enterprise-wide business definitions, essentially a unified glossary. Two, share that operational context right alongside the data payload itself. Three, build intelligent connections that automatically validate meaning, completely abandoning the old model of dumb integrations. And four, close the enterprise knowledge gap by ensuring all interconnected systems speak the exact same operational language. By rigorously applying these steps, an organization transitions from just moving raw files around to exchanging truly meaningful, actionable insights across all of its supply chain and corporate systems. I want to leave you with a critical strategic question to consider today. Is your enterprise successfully communicating, or are you just perfectly exchanging data that no one understands? As you evaluate your future IT budgets and your architectural roadmaps, you really have to objectively ask yourself, are you funding permanent semantic engineering solutions, or are you simply paying a recurring premium to clean up after dumb integrations?
Hello, this is Randy McClure from SC Tech Insights. Thank you for listening. For more on this topic, click the article link below or go to www.sctechinsights.com for the latest insights on supply chain technology. Thank you and see you next time.